This lesson is October 10th's homework, which was 4.2 practice, rate of change of linear functions. So in this lesson, we learned that for a function to be linear, it has to have a constant rate of change. So it has to be adding or subtracting the same amount every time. Specifically, linear functions have slope because we can use the term slope when we're referring to a line. So our lines have to have a constant slope or constant rate of change throughout the entire function. So question number 1 on homework told us that Jeff Morden drives 140 miles in 4 hours. So part A, what is his rate of change? Well, if he goes 140 miles in 4 hours, we want to know how many miles he goes in 1 hour. That could also be referred to as a unit rate. That's something that you discuss in 7th grade math. So if we were to reduce 140 divided by 4, it should tell us that that is 35 miles for every 1 hour. Part B says represent this situation on the graph. Okay, so that's telling us that at 0 hours, didn't go any miles, but 1 hour later, should have went 35 miles. 2 hours later would have went 70 miles, and then it will increase by 35 every time. So it goes up 35 over 1, up 35 over 1. So you just needed to plot a couple good points showing that your rate of change was 35. And if I was specifically thinking of it in terms of slope, it's rise over run, and so 35 over 1 is the slope. We specifically have to be careful when we have graphs that are labeled with units that are not 1 on both axes. So the y-axis is labeled in increments of 35 based upon that being the increase in the y every time in our miles. And then the hours were just labeled with 1. So it is not like a one-to-one situation. So always be careful with the units that the axis is labeled with. Question number 2, Claire and Rachel play volleyball for different teams. Claire's team practices 7 hours every 2 days, and Rachel's team practices 8 hours every 3 days. Match each player to the graph that represents the average number of hours that they practice each day over a 7-day period. Okay, so we've got Claire, who practices 7 hours every 2 days, and Rachel, who is 8 hours every 3 days. So if I were to think about that in terms of rate of change of slope, we've got Claire practicing 7 hours every 2 days. That's for Claire. And then Rachel practicing 8 hours every 3 days. And so if we were to actually try to convert that to over 1, we can see these do not go evenly. So Claire, 7 divided by 2 is telling me that it's approximately 3.5 every 1 day. And Rachel's is actually going to come out to be a repeating decimal because 8 divided by 3 gives me 2.67, well, 2.6 repeating every 1 day. So Claire practices approximately 3.5 hours every day, and then Rachel's team practices approximately 2.6 hours every day. So on the graph, we would be looking at, we could technically, depending on how it's labeled, look at either one of these. But because these are counting up by 1s on both of the axes, I can't necessarily always see these decimals. So I'm going to try the original rate of up 7 over 2. So if I go up 7 over 2, this must not be matching Claire's, but if I go up 8 over 3, I see that's where it crosses through evenly again. So this must be matching Rachel's rate of change. So remember, rate of change, or slope, is how much the rise is over how much the run is. So it went up 8 units, so 8 hours, so up 8. and over 3. So the slope would be 8 over 3. Well, that matches what we described for Rachel. So the other graph goes up 7 over 2, and then it crosses through another even point. So this must be representing Claire's. Now, both of these graphs, much like the one before it, are directly proportional. They are technically called direct variations in algebra, but in 7th grade math, you talked about them being proportional because they're going through 0, 0. Question number 3 says Steve is trying to increase his average pace per mile by running hills. The hill on First Avenue rises 3 vertical feet for each horizontal foot. The hill on 16th Avenue rises 1 vertical foot for every 3 horizontal feet. Okay, so first of all, I am not going to even pay attention to the street names because some people were going to get too caught up in that. Those numbers are just part of the street names. I'm going to focus on the vertical change over the horizontal change. So it says that the first one goes up 3 over 1. That's the first hill. The second hill rises, has a vertical change of 1 for every 3 horizontal feet. So rate of change or slope is your change in y, or your vertical change, over your change in x, or your horizontal change. So it's change in y over change in x. So I'm writing these little triangles because this symbol means change. So change in y over change in x, or the rise over the run. So the first hill really just has a rate of change or a slope of approximately 3. And then the second hill has a rate of change of approximately 0.3, repeating. Which hill would be more difficult for Steve to run up? Explain your reasoning. So it says the hill on First Avenue would be more difficult because it has a value of 3, which is steeper than the slope of the second one, which is just 1/3. So we remember the higher the slope, the more steep the line is, or the more straight up and down vertically it becomes. And if you can imagine, running straight up a hill would be pretty much impossible. You'd be climbing a cliffside. So if your hill has a slope of 3, it is going to be more difficult to run up. Question number 4, the following graph represents the amount that Camilla and Lydia charge for their babysitting services. So we have our graph. We have the linear function that represents Camilla and the linear function that represents Lydia. I know they're linear functions because they are literally lines on the graph. The y-axis is labeled with charge for babysitting. The x-axis is labeled with number of hours babysitting. It says which of the following statements are true, select all that apply. So we can see here there are 3 correct answers. So let's understand why those are correct. The rate of change of each line represents the amount each girl charges per hour for her babysitting services. Well, if the rate of change is the change in y, so the change in the y-axis over the change in the x-axis, that would be the change in the charge for every hour. So this is what it says, the charge per hour. So the rate of change, regardless of what it is representing the charge per hour. That's why that is correct. Lydia's rate of change is greater than Camilla's rate of change. Well, if that were the case, then Lydia's line would be steeper, or like above Camilla's line. That is not the case. If I actually went in and found some good points and found out how much Camilla charges per hour versus Lydia's, it's going to be more. Lydia's rate of change is $7 per hour. Well, to find that out, we would have to find a good clean point. So this is the first place where I see the line goes perfectly through the corner of the boxes. So that is the point I'm going to use. I can't really use any of these ones that are cutting through the middle because I'm kind of guesstimating what those values are. I have to know for sure what the x and y value is to find the rate of change. So if this had not been a proportional line, if it had not gone through 0, 0, I would have needed to find another good point and do y2 minus y1 over x2 minus x1. Technically, 0, 0 is another point, and I could do that with these 2 points. So I would have the ordered pair 5, 45, and 0, 0. So if I want to do it this way, I can, but I'm just doing it to show you that it's really the long way for a proportional line, because this would be 0 minus 45 over 0 minus 5, which is just negative 45 over 5. So it's really just the same thing as a 45 divided by 5, which is really the original coordinate to begin with. And 45 divided by 5 gives us a rate of change of 9. So that was for Camilla's rate of change. To find Lydia's rate of change, I see a good clean point right here at the point 535. Now that I understand this is a proportional line, so I could really just find the rate of change by doing y divided by x, 45 divided by 5, I'm going to use that shortcut with Lydia at the point 535. And I see that 35 divided by 5 tells me that Lydia's rate of change is 7, so $7 per hour is correct. Camilla charges $35 for 5 hours of babysitting services. Well, if that were true, at 5 hours, Camilla would have her line, her linear function would be falling on 35. Well, that's not true. That is what is true for Lydia, but not Camilla. And then Lydia charges $14 for 2 hours of babysitting services. So at 2 hours, it's approximately at 14. It's a little bit below 15, so that is true. Question number 5, Keon and Leisha are comparing their daily caloric intake. Each day, Leisha chooses healthy 100-calorie snacks, such as apples and carrots, while Keon chooses snacks like chips and candy that have 200 calories each. Part A, you were supposed to draw a graph to represent Keon's and Leisha's caloric intake based upon the number of snacks they eat, labeling each line and the axis. So the independent variable here, the thing controlling the situation, is going to be the number of snacks, and then that's going to affect the total caloric intake each day. So you could have labeled your axis with different numbers. Specifically, here we suggest that the scale for the horizontal or the x-axis should be in ones, and the scale for the vertical axis, since things were in the hundreds range, should probably be increments of 100. So if I have the y-axis labeled in hundreds, you could have just skipped every other one as long as we could see that you were counting by hundreds. That's all that mattered. And then the x-axis counting by ones. I see that Leisha had only 100 calories per snack, and then Keon had 200 calories per snack. So to represent Leisha, who had a healthier choice, for every one snack, it's only going to give us a difference of 100 calories. So it goes up 100 calories for every one snack, up another 100 calories for every one snack. So Leisha's line should be going through each of the boxes based upon the way that we labeled it. Now Keon's is going up 200 calories for every one snack, so it would go up 200 over 1, up 200 over 1. And so this blue line on my particular example would be representing Keon's rate of change, which was 200 calories per one snack. Part B, what does the rate of change for each line represent? It represents the amount of calories per snack, because that is your change in Y, which is the caloric intake or calories, change in Y, over the X or the independent variable, which was the number of snacks. So calories per number of snacks, which in normal language we would just say calories per snack. Part C, what is Alicia's rate of change? Well, really it should boil down to 100 calories per snack. If you had given it another rate, it wouldn't have been the most simplified. Remember, we simplify our slope or our rate of change down as far as we can, and we know it was 100 over every 1, so it should be 100 calories per snack. Part D, how does Alicia's rate of change compare to Keon's rate of change, and why are the two rates different from one another? Well, in this case, it doubles. The rate of change are different because of the healthy snacks versus the unhealthy snacks. So we already know that Alicia's rate of change was only half of Keon's rate of change, simply because he was choosing snacks that were twice the caloric value of Alicia's snacks. Question number 6, Steve repairs elevators. When he's called to a job, he uses the stairwell to go to the floor on which the elevator is located. In the Modus building, he climbs 22 steps for every 15 feet of horizontal travel. In the Sears Tower, he climbs 17 steps for every 7 feet of horizontal travel. So part A, what is the rate of change for each stairwell? Well, in the Modus Tower, they told us we went up 22 over 15. So if we calculate that, it's approximately 1.47. In the Sears Tower, we went up 17 and over 7. So if we calculate that, that is approximately 2.4. So for part B, which stairwell will be easier to climb? Explain your reasoning. So we're looking for the one that is less steep. So the Modus building staircase will be easier to climb because the Sears Tower staircase is steeper. When we look back at our rates of change, the higher number, remember, gives you a more steep line, which means that that is going to be a steeper stairwell and it's going to be harder to climb. So Modus would be easier. Question number 7, J.K. Rowling and R.L. Stine are both reading The Hunger Games. J.K. reads 35 pages every 2 hours and R.L. reads 45 every 3 hours. So the rate of change per each reader, we're kind of basically reducing it into how many pages per hour. So 35 per 2 is approximately 17.5 per hour for J.K. 45 over 3 is 15 pages per hour for R.L. Stine. Part B, if The Hunger Games is 355 pages, who will finish the book first? So whoever has the higher rate of change. J.K. has the higher rate of change, so she's going to finish the book first. Jose drives 65 miles per hour when he travels. Sherry drives 450 miles in 9 hours. Which driver has a faster rate of change? Well, they actually gave us Jose's flat out. They told us it was 65 miles per 1 hour. To find Sherry's, we would have to reduce what they tell us, the 450 miles every 9 hours, to find out how many miles per every 1 hour, which would be our rate of change, or technically our slope as well. So 450 divided by 9 tells me that that's 50 miles every 1 hour as compared to Jose's 65. So Jose is going to drive at a faster rate. He's going to be speeding faster than Sherry. Question number 9, the following graph represents the money Matthew and Mitchell spend each hour when they play video games at a local arcade. So paying attention to the labels on our axis, the y-axis is the amount of money spent in dollars, and they're counting by fives. The x-axis is the hours playing video games, and they're counting by ones. So watch out for that when we're looking at the rates of change. It says, which of the following statements is true? At this point, we can see that B is the correct answer. It says the rate of change represents the money the boys spend per hour playing video games. Well, again, remember the rate of change is the change in Y, here this Y being the money spent in dollars, over the change in X, and on our X-axis, that's the number of hours playing games. So what they said is an accurate representation of what the rate of change would be for this graph. So let's look back at A, C, and D and see why those are not true. A says Matthew is spending his money at a faster rate than Mitchell. That would mean that Matthew's line would have would be steeper, would have a higher slope or higher rate of change, which is clearly not the case. Mitchell spends $3 every hour he plays video games, so If I look at Mitchell's and I look for a good clean point where the line is going through the corner of the boxes, the first one I see is right here at 540. So the ordered pair 540. Again, these are going through 0, 0, so they are proportional. They are technically called direct variations. When the lines are proportional, I don't have to have two ordered pairs to find the rate of change. I can simply divide y by x. So 40 divided by 5 comes out to be 8, so that is not true. Matthew spends $5 every hour he plays, so if I look for a good clean point here, it looks like it's going up approximately every one box. It's kind of a little bit blurry, but it looks like it's going every one box here. It looks pretty clean, which is up 5 over 1, up 5 over 1. So Matthew does spend $5 every hour he plays video games. So that is also another correct answer. So the two correct answers are B and D. Last question, number 10. Mrs. Cugini, I suppose, collected data on the hand span length and height of each of her Algebra 1 students. The graph below represents the scatter plot of the data for one class. So this data is provided in the form of a scatter plot instead of just a complete line, because these are just individual data points taken from students within her class. And so while there is not an exact measurement of growth that correlates your hand span to your height, there is some kind of correlation going on between this data. It's just not a perfect linear trend. So when we have scatter plots, we can draw this thing called the line of best fit, and it's the line that best models the data. This line should fall approximately in the middle of the data points to show the trend of the data. So we see that this is increasing overall, and if you were to draw your line, you would have to draw it as close as you could through the middle of those data points, and then you would have to approximate what the rate of change would be. So for this particular question, there is no exact one answer because we're doing it by hand. It is going to be an approximation. So your rate of change, your increase in height over your increase in hand span, should fall within the range between 5.9 to 6.3. If you reduce it all the way, it should fall reasonably within those numbers. Now, if it falls way out of there, then you must be way off with the way you're drawing your line. Just make sure that your line, as best as possible, goes through the middle of the data. So, for example, you want to draw it preferably with a ruler and not freehand, and you want to try and make sure you have the same number of dots above as below. So here I've got 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. It's close. I've got one more below than above, but I just kind of eyeballed it and tried to draw it through the middle of the data and saw how much it went up over how much it went over. And so you should just do that, find some clean points, find your rate of change, and it should fall within this range. Part B, what does the slope represent? Well, just looking at our axes, we know that's the change in y over the change in x. And so for the labels here was the height of the students over the hand span length, so hand length. So it's the height over the hand span. So the average rate of change in height in inches in relation to the change in hand span length in inches. For each inch the hand span increases, the height of the person increases on average around 6 inches. Okay, so there are a couple different ways you could have said that, but the main point is that it is the height over the hand span. So that whole lesson was really just remembering that if it is a linear function, it must have a constant rate of change, and then we were getting into looking at how do you find the rate of change from the graph and what does it actually mean in context of the scenarios.